So can you see even the slides? Yeah.
Yes. See.
Okay.
Yes.
So well, in previous meetings, I talked a couple of times about assessing or studying the robustness of satellite constellations using complex networks, because complex networks is my topic of research. And recently, with Juan, we reviewed a paper called Modeling and Analysis of Cascading Failures in LEO satellite networks. Yes. This paper proposes to use complex network techniques to model cascading failures in satellite networks due to overloads. Overloads here are data overloads, like the buffer capacity and the processing capacity. In this work, using the proposed cascading failure model, the authors analyzed the cascading failures vulnerabilities of the network under cyber attacks or targeted attacks in particular. Here, in particular, they tested first removing the 3 nodes with the highest loads, black holing attacks, and false routing information attacks. Now, I'm going to talk a bit more about the model and the assumptions they made. I'm going to explain the reason behind explaining all of this in just a minute. But first, I want you to focus on how did the authors of this paper presented this model. First, they assume that each satellite establishes permanent links with 4 adjacent satellites, so like a grid. And they mentioned that it provides this global coverage except for the north and south poles. That's what's stated in the article. Also, the communication between users with access to satellites and those without access to satellites will involve gateways. Here, a gateway consists of a group of large antennas and equipment, which can establish connections with multiple satellites inside. And it also acts as a relay facility for satellite networks and the backbone of the terrestrial internet. Here, at each moment in time, at each period of time t, basically, the satellite receives data packets from all users within the coverage area, plus data packets from the neighboring satellites. Also, the data received by a satellite is stored in the buffer of the satellite. And those data packets can be processed by the satellite, and the data packets that can be processed by the satellite will be forwarded to the gateway serving the target, and those that are unprocessed are saved until the next moment for processing. So they will be stored if the processing capacity of the satellite is not enough. Here, the gateway receives the data packets sent by all satellites inside and stores the data in the buffer. Then, this data is forwarded to the terrestrial internet according to its processing capacity. And then again, the unprocessed data packets will be saved and processed later. Finally, it is assumed that the speed of the data packet transmission is much higher than the flight speed of the satellite, and thus the topology doesn't change. This is important for the model because this way they don't really have to worry about any changes in the communication pattern. Now, to summarize this model, what we have in the model as a, let's say, as a graph model. First, there are satellite and gateway nodes. They are distinguished because some of the formulas are different. The nodes have storage and processing capacities. The network topology does not change because they assume that all these processes go much faster than changes in the topology. The processing capacity will degrade with the buffer load. So the more data you have in the buffer, the more difficult to process the data becomes. Also, nodes will fail due to overload when the unprocessed load exceeds the capacity. Also, nodes can fail because they become isolated, which is fairly reasonable. If they cannot send data anywhere, then they consider it to have failed. And the node load behavior, I mean, how the loads move within the network is determined by the routing scheme. In this regard, the model offers a lot of, a lot of parameters that can be adjusted to simulate different routing schemes, but a lot of this is just heavily dependent on how we are routing the data. So what I'm trying to say with this, here I try my best to translate a bit the original formulas because they were written with a relatively harsh notation. So I tried my best. And here, I know there are a lot of things. I'm not trying for you to understand everything right now, but the model is quite simple. Here, I don't know, can you see my
yes,
my pointer?
Yeah, we can see the equations.
Okay. Yeah, okay. But here, what I want you to take away is that we can see a bit more about how the loads are modeled. And we can see that the total load of a satellite or gateway is in part determined by the data left to process, which was what I just told about the processing capacity of a node being degraded because of the load that the buffer contains. And this can be seen in particular here. For example, this is for a satellite, but here we can see that there is this L left is the unprocessed load, and this is the maximum processing capacity. So if the load left within a node is rather small, and what is small is something that can be tweaked in the model as needed by these parameters here. If it is slow enough, then it will be processed at maximum capacity. If it is in between the maximum capacity and these tolerance parameters, then it degrades with this delta here. And once the load, the data load that's contained in the buffer surpasses this maximum capacity, then the processing capacity of a node is totally degraded. And so it is unable to process any data and becomes overloaded. Okay, a lot of these formulas are very much the same for gateways and satellites. There are small differences in the total load and whatnot. But I think the most interesting thing to see about the formulas, because there are more, is in particular this degradation in the processing capacity and how they define the overload of a node. And here we can see the L route, which is basically the load that's determined by the routing scheme at that certain point of time. So this is entirely dependent on how the routing scheme being used works. And in that regard, this load model is not, let's say, it's not blind to the routing scheme, but rather it heavily relies on the routing scheme to function, to the models, which is something that maybe here doesn't sound as impressive. But trust me, I've seen a lot of modeling of loads in complex networks that really doesn't care about how the loads go anywhere. They just assume that they behave magically in a natural sort of way. But I really like that here they do really the routing scheme, and you need to use the routing scheme because, well, it's a routing problem. Of course, it's important. So I wanted just to show this briefly. And now, in the papers, future work, they state that as future work, they would like to focus on a cascading failure model for high-speed satellite movements, which is indeed very interesting because in that regard, they would have to account for changes in the topology. Now, of course, I'm presenting this to you because I believe that we could expand a bit more using techniques that I used in the thesis. Now, let's do a brief recap about what I did in my thesis. And this is very brief because I already presented this to you back at the workshop. But basically, I studied the robustness of interdependent networks or networks that interact with each other. And in particular, I considered a consumer-provider behavior. The fun thing of the consumer-provider behavior is that you have basically an origin and destiny. You can interpret this that way. In particular, I tested the effects of attacks that affect an area, such as localized attacks that we see here, or localized attack with probabilistic failures, which was part of my thesis. Now, why is this useful for satellite networks? What's the relation? And well, as we know, satellite constellations can be represented as temporal graphs, using a graph representation that allows us to approximate the behavior of the whole network under different scenarios. We can represent these graphs as content graphs like this, which I'm pretty sure we are familiar right by now. And they can also be represented as multi-layer networks like this. This is basically an interdependent network system, which is basically what I worked on during my thesis. That's the relation 1, let's say. And not only that, but attacks that affect an area, which I worked with those two, can be used to model damage caused, for example, by military-grade threats, such as missile attacks, which is fairly different from a cyber attack, because you can affect a whole area. And it doesn't necessarily need much more than destroying the thing. It's not as much as degrading like a cyber attack or rerouting, but just plain destroying. So that's a different approach. So what can we do with this and with the work that I just talked about? Well, first, of course, we can study the robustness of the system as a whole. In particular, we can expand the work that was presented in this paper I just showed you. And how? First, we can use the load dynamics considered in the model proposed in that paper to test what happens if instead of cyber attacks, we test localized attacks, or what happens if an area is affected by an attack. With this, we could try also to answer the question of how much damage can the network take before 2 points in the world become unable to communicate, which is not exactly the same question, the question that they were trying to answer in the paper, because they were very much presenting the model. And also, we could try to see how the damage propagates over time, but over time, not like in this instantaneous way, but over time as the topology changes. In that regard, I do need help from you and opinions, because I have to say that I'm not that familiar on whether the networks we're working here are high or low speed, or how the load propagation works relative to the speed of the changes that we can see on the topology. But depending on that, we could potentially expand on this part without necessarily doing that much to the formulas. For example, just adding the layer of the contact graphs or temporal graphs part. So this is a bit of what I think we could do. But I would like to know if you have any other idea of what we could do with this. Thank you.
Excellent. Thank you. Thank you, Ivana. I will pause the presentation so that the recording, sorry, so that we can just chat. So